What are the impacts of genset running in underloaded condition? How PV Genset controller fixes that? By the end of this video, you will get to know the implications of a generator running in low or no load condition. This also covers how wet stacking of generator set is handled by PV Genset controller once grid-tied solar is integrated into the system. Hi, I am Shaf Ali from ICSS Engineering. We specialize in solar SCADA and control systems required for safe and productive integration of grid-tied renewable solar energy in existing power infrastructures of industries and commercial applications. What is underloading or wet stacking of a generator? Underloading a generator is the practice of running generator with a lighter load than it is designed for. The endothermic engines that are used in generator sets have been designed to use as much power as possible, from 30 to 100% of the declared maximum power. A diesel engine needs to operate under substantial load to reach its optimum operating temperature. If it fails to reach this temperature, then a percentage of fuel will be unburnt and a buildup of soot can occur. Following are the other repercussions of running generator in underloaded condition. Number 1. Low cylinder pressure. Diesel engine works by compressing hot air into an extreme extent so that when fuel is introduced into the cylinder, it ignites without the need for a spark plug. As a result, high cylinder pressure is integral to the proper working of the engine. When a generator is being run at low load, low cylinder pressure results in poor combustion, decreasing the efficiency of the engine. The poor combustion causes a cyclical issue. Soot and unburnt fuel residue clogs the already poorly sealed piston rings, making the low pressure problem even worse. Number 2. Low temperature. At low load, engines cool and run at a temperature insufficient to create proper combustion. This also causes fuse to be only partially burned. In addition to deposits, this can lead to a lot of exhaust emissions. Exhaust is the familiar white smoke seen in poorly operating diesel engines. Smoke which is dangerously high in hydrocarbon emissions. Number 3. Internal grazing of the cylindrical bores. This is a phenomena that is often a major culprit behind diesel engine damage. Hot combustion gases escape past the piston rings and instantly burn the oil lubricating the cylinder walls. This result is a smooth enamel-like glaze along the cylinder walls, which cover the grooves meant to hold the cylinder lubricating oil and transport it from the crankcase. This results in increased wear and tear due to under lubrication and increased oil consumption. However, it is not the only load side effect that causes this problem. Number 4. Lower oil performance. High oil consumption. Low load operation wreaks havoc on engine's oil distribution system in a number of ways. Hard carbon deposits are formed as a result of poor combustion, cause bore polishing, destroying the honing marks for the oil. The oil burns and oil consumption increases. Due to the poorly sealing piston rings, unburnt fuel contaminates the lubricating oil, as does condensed water and residue, which cause a destructive acid buildup. Number 5. Increase of exhaust smoke. The white smoke caused by unburnt fuel due to low temperatures has already been mentioned. However, this is not the only increase in pollution caused by low load operation. Oil leaking past the poorly sealing piston rings into the combustion chamber is burned and causes distinctive blue smoke, while black smoke is the result of damaged injectors. Number 6. Sticking of the piston rings. Number 7. Reducing compression. Number 8. The presence of traces of fuel in the engine oil. Number 9. Excessive wear of the turbocharger. Number 10. Excessive oil leaks in the body of the turbocharger. Number 11. Increased pressure in the gearbox and the crankcase. Number 12. Excessive deposits of carbon residue on the surface of valves, valve seats, pistons and the exhaust manifold. Number 13. Hardening of the surfaces of the cylinder liners. To summarize above mentioned points, if generator is running in underloaded condition, following adverse effects may occur: increased maintenance cost, increased operational cost, liability of generator decreases, can lead to collateral damages on generator's components. The above damaging occurrences have a cumulative effect on generator sets. First, users are likely to observe unexplained power losses and intermittent poor performance. This is due to the inefficient operation as well as highly accelerated wear on components. Soon, components will begin to fail, resulting in unscheduled maintenance and increased downtime. At a certain point, glazing and carbon buildups become so extreme that completely stripping the engine, reboring the cylinders, and machining new honing marks is the only solution. Regularly running generators at low or no load will without a doubt eventually result in total generator failure. PV Genset controller knows which generator is running, what is its minimum genset loading set point, so it increases or decreases solar generation, always ensuring that generator never gets underloaded. We have and will be covering more topics related to PV microgrid design, PV genset controllers and solar SCADA monitoring. Check out this video's description for the links. You can browse this YouTube channel for PV genset hybrid projects based on Energy PK PV diesel controller. You can also visit our website www.icssww.com for details. For local and international Energy PK PV diesel controller inquiries, fill in the Google form link provided in the description or contact us through email, call, WhatsApp, email or WeChat. We are glad to offer much required solar operation and maintenance SCADA system called PV SCADA Max. PV SCADA Max is a complete O&M SCADA solution for medium, large or very large scale PV solar integration projects. Salient features of PV SCADA Max are high level of scalability from 100 kilowatt to multiple gigawatts, real-time monitoring of each grid-tied solar inverter and its respective strings, real-time alerts and alarm logs in case of any alarms on inverters, real-time monitoring of energy mix between various sources, for example grid, solar and generators against weather data, transparency of energy generation and consumption reporting, historical trending of parameters, integration of data from third-party SCADA control equipment or process-sensitive instruments, fact-based data for root cause analysis. For local and international Energy PK PV diesel controller inquiries, fill in the Google form link provided in the description or contact us through email, call, WhatsApp, email or WeChat. Thank you for your time. Thank you.